Hi, this is a complete energy management solution which actually monitors the energy consumption of a factory which has 3 floors, and in each floor there are actually different number of machines. For example, this floor 1 actually has 3 machines, floor 2 has 2 machines, and floor 3 has 2 machines. This is actually the energy map, and the blue color actually indicates that we are at the factory level. Now, to the right we can see the current consumption at the kilowatt hours per unit production, and this number actually shows what is the current level of this. And you can actually go to different levels. For example, you can actually click here and go to the factory level consumption, and you can actually see the percentage change from benchmark here. Now if we have a red mark, it means that there is an alert, the current consumption has crossed certain levels, and we can actually go to the tick by tick data here, and this will show us how the consumption, actual consumption, which is shown in green, is different from the baseline. And the person who is actually watching can actually find out what went wrong when it started to go beyond the levels that it was expected to be. And the actual cost versus baseline is also provided at the factory level for this dashboard. So there are these two dashboards at the summary level. Now if we go back to the original dashboard, we saw the percentage change from benchmark here. Now this month actually shows we have this data for 2 months, one for the month of November and the month of August, and the panel here shows the floor level consumptions, and it will flash different colors. The warning level is the orange level that is currently showing up for floor 3, and there are two other levels, the green and the red. If it is critical, then it shows red, and if it's normal, it will show green. Now the consumption across the floor levels, the distribution across the floor levels is shown here. For example, we can see that floor 3 actually has the bulk of the consumption, and it varies over time. This can be seen here, and according to the this particular dashboard, we can see that the leakage percentage is 22.24%. Now what is the leakage? The leakage is actually the energy that is not being put to fruitful use. So this is the energy that is being consumed, but no useful work is being done. Now we can see that the machine level has come up to be a critical level. So we can actually go to this dashboard and look at the machine level to find out what's going wrong. For example, we saw the machine 1 had actually crossed the threshold at this time, and so we see that the machine 1 is behaving erratically. It is actually crossed the upper threshold, and that is the reason why this dashboard actually showed at a red color. And since the power consumption has crossed the threshold, it is interesting to find out what actually went wrong at the voltage volt level and the amperage level, and this is available if we go below. We can see the actual cost versus baseline, we can have the actual voltage and actual current consumption versus baseline here. So if we go back to the dashboards, now we can actually go back to the factory summary. So this is the general panel. From this panel we can keep tabs on whatever is going on at the factory, and we have similar dashboards for the floor summary, which tells you everything that is going on across the floors. Now what we will look at is what we have for the machines. So the machine level summary will actually show us that we have firstly the similar information on the consumption and the change from benchmark, and we also have gauges to show how the voltage is actually changing from benchmark and the amperage is changing from benchmark. We also have the location of the machine to identify which machine we are talking about and where it is located. Now if we go back, we can find out that we also have an alert dashboard. This alert dashboard highlights which machines are currently out of order, and we have actually stored this information, this date time information, so that we can review the machine level details by finding out what went wrong. For example, if we know that machine 1 went out of order at a certain amount of time, then we can actually go back to the machine level consumption dashboards and find out what actually went wrong for this particular machine and when it actually crossed thresholds. So this we can find out, and we can actually compare with the baseline the current consumption and the power consumption, so that we find out what exactly was the root cause underlying this breach. Now we also have the prediction and anomaly detection dashboard. This dashboard actually summarizes our prediction model and the anomaly detection models. Now, since we have already seen how thresholds have been used to identify when an alert is being generated, this is a different way of finding out the alerts. We are using here the DB scan method. This actually uses the clustering method to find out which points cannot be entered. See, the DB scan cluster actually identifies those points that lie within a cluster of points within an epsilon epsilon neighborhood, and we determine that there should be at least 5 or 6 points or 10 points, whatever, based on the context, what should be the correct number of points that should reside within that epsilon neighborhood for it to belong to a cluster. Now, if there is a point which cannot be included in any clusters, then obviously it is different from its neighbors, and it is those points that are identified as anomaly here. So this is a unsupervised way of detecting anomalies without user defined thresholds. And the first dashboard here actually shows how anomalies are being detected, and we can see that there are certain points which are being detected as anomalies, which probably would not be an anomaly simply from the threshold point of view, but it is different from the surrounding points, and therefore they have been identified as anomalies. So this is another view which allows you to identify anomalies from a different context. Now we also have the energy consumption prediction based on past data, and this prediction actually allows you to prepare because you know beforehand how much energy you are likely to spend in the next point of time. See, that can be 1 day, 1 month, or 1 hour also, whatever you choose. So you, based on past data, you can actually predict what is going to be the energy consumption in the next particular point, which can be a day ahead, 1 hour ahead, or a month ahead. And this will help you in planning your energy purchase, and also it can actually help, because this is done for the energy consumption data, but it can also be used to predict when the next maintenance is required based on when another alert is going to be generated. So this is just one example where a prediction method has been applied, and you can see that it is actually quite accurate, because the root mean square error is 0.1, and very often the difference between actual and predicted energy consumption is very, very small. So this is all for here.